All right, we're going to start Unit 6, probability. I'd like you to match the phrase with less than. Notice some of them have less than or less than greater than. So notice it has an equals or it doesn't have an equals. So does the phrase, can it be that number, or does it have to be greater than or less than that number? See if you can match, because you're going to see these phrases used in these upcoming exercises. Here's a hint. See what you can come up with. Now, the thing about the probability unit, nothing like anything else we've done. So we're taking, it would be like if I had given you an Algebra 2 book, I would have taken it up. At one point, I might have given you a geometry book, then I would have had to take that up. And at this point, I would have to give you a probability and statistics book, and then probably take that up. That's the thing about what they've done with Math 1. It's no longer called algebra, it's called Math 1, Math 2, Math 3, because they're trying to integrate different topics. This is our last unit. It's going to be quick. We are taking a test next Tuesday. We should have sufficient time, barring no more bad weather and shortened class periods, to get finished without too much of a rush. Okay, we're going to talk about probability distribution, and we're going to talk about the first example of rolling 2 dice. If I were just to take 2 dice, a red and a blue, or in this case a red and a green, and I've given you a grid. Do y'all see a grid there on your paper? Okay. And notice that it says number of green die, number on the green die, and down the side it says number on the red die. Everybody see that? And what it is this is a place for you to record every possible outcome. Okay? For example, I could roll the 2 dice, toss them down, and I could have a 1 on the red, and what else? A 1 on the green. Does that make sense? What else could I have? I could have a 1 on the red and a what? 2 on the green. You're going to fill in yours. I'm going to fill in mine. I could have a 1 on the red, a 3 on the green, a 1 on the red, a 4 on the green, a 1 and a 5, a 1 and a 6. Take time right now to fill in all of the items in the table, or in the grid in the chart. Then we're going to answer some questions related to what we see in the chart. All right. It's just a matter of actually following the pattern, right? One number and another number up to 1, 1, 1 on each dice. And the bottom corner is what? 6, 6. Now, first question, it says, what does 3, 2 mean? 3 on the red die. Okay. 2 on the green. That's all that means. And it's part of your understanding is, do you realize what it's talking about? How many possible outcomes did we see if we wrote out every single one in a very organized way? 36. It's a 6 by 6. 6 possible numbers on the dice, each one. 36 is the possibility. What is the probability of getting a 4 and then a 1? A 4, 1. What is the probability? We have, how many chances do we have? Only 1, right? There's only one time. It didn't say a 1 and a 4. It says specifically 4 first and 1 second. So there would only be one time that would happen, and that would be right here. So my chances are going to be 1 chance out of 36. Now, from this point on, we're going to use that grid, that graph you have. What's the chances of getting doubles? So what do I mean by doubles? Same number twice, right? How many chances are there? Be 6 out of 36, because you get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. For now, For now. A lot of us are accustomed. Now, 6 chances out of 36 would reduce to what? 1 chance out of every 6. Okay? A lot of this right now, for our purposes of what we're trying to do, we're not going to necessarily reduce those. Now, most of the time you will, but for today, as we get started, we're not necessarily going to do that. A sum of 7. A sum of 7. It didn't specify that it had to be a bigger number than a smaller number. A sum of 7. Do I have any sums of 7 in the whole first row? Okay. I could do what? 1 and 6. That's one sum of 7. Anything else? Got a 2 and a 5. Okay. Then you got a 3 and a 4. You got a 4 and a 3. 5 and a 2. 6 and a 1. How many chances is that? 6 out of 36 again. All right. Why don't you try F, G, H, and I? Please read it carefully. Now, when it says a 2 on at least 1, or, do you think that word or is important? Yes, it is. So, do you think there's a bunch of chances that I'll get 2 on at least 1? And then are there more chances that I'll have a sum of 2 that I could add to that? Okay, let's just do them together. Let's go ahead and do sum of 11. How many chances do I have? Only 2. There can be a 5, then a 6, or what else? A 6, then a 5. So there's only 2 chances out of 36. Okay, a 2 on at least 1 die. How many times do we have a 2 on at least 1 die? And I'm going to go, and I don't have all my ingredients. I should have done that. 2 on at least 1 die. It's a 2 right there, right? 2, there's a 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 2. There's a 2, there's a 2, there's a 2, there's a 2, right? Is there any others I missed? All of the ones I just circled came from the first part. Everybody get that? And then what's the next one? Or a sum of 2. Do I have any that would sum to 2? 1, 1, right? So that gives me 1 fewer or 1 extra? 1 extra. How many does that give us? 1, 2, 3, 4, 5, 6. How many chances? 12. 12 out of 36. Did everybody get that? Did I mess something up? What is it? Huh? Did I miss something? Okay. What do you think is important when it says doubles and a sum of 8? They have to include both requirements. Do I have any doubles that also sum 8? 4 and 4. That'd be right here, right? That would be the only case because and it lessened the number of chances I had. As soon as that word and came in there, I go from having more chances to fewer chances because it has to meet both requirements. So I need you to kind of pick up on it. There's a difference between the word or and the word what? And. All right. What about I? Doubles or a sum of 8? Is that going to give you more chances or fewer chances? It's going to give you more, isn't it? You got it yet? What'd you get? Doubles or a sum of 8? Sum of 8. Doubles or a sum of 8. How many doubles do we have? We have 6 that I know that for sure that are doubles. That's 1, 1, 2, 2, 3, 3, 4, 4. Sum of 8. Any in the first row sum to 8? No. Any in the second row sum to 8? Yes. In the third row? Yes. Whoa! That one's already there. So how many extra did I get? 4 more extra. That one would have been counted twice, correct? But I don't count it both ways. So I would have had doubles. Oops, sorry. Doubles would have been down this diagonal, and then these 4 extra. So how many does that give us altogether? 10 chances out of 36. So as soon as that word or came in, I actually increased the number of chances. Does everybody feel pretty good about that? It's just about thinking it through. All right, let's do something else. Okay. This time it says, give your answers for probabilities. We're calling this, I need you to kind of know, you know how when we took the time to write down every single possible thing that could happen, 1, 1, 2, 2, 1, 3, whatever it was? When we gridded out all 36, that was called a sample space. It's a list of all the possible outcomes, okay? And it's great to do that, especially if we're talking about a limited number. Now, if I had 1,000,000 possible outcomes, I would never want to take the time to write down 1,000,000 things. But when I have something that that's very possible, I need you to try your hand. Oh, we already did these, didn't we? We just do these? We did these on the other page, didn't we? Okay, here was our answers. But you already got them. Sorry, it's a repeat. My bad. Oh, there is something that I don't think I wrote this on there. I didn't type it in there. But does this make sense to you? What does it mean to be equally likely?
It means
that means if I just reach out in random and pick a card, hopefully each card has an equal chance of being chosen. Okay, it's not like one's thicker than the other or one's textured differently than the others. One's not different. They all have an equal chance. So equally likely. All right, number 2. Probability distribution is a description of all possible numerical outcomes. Complete the probability distribution for the sum of the 2 dice. You guys have a table right there, right? Here's my sum right here. Y'all have this chart? And you're going to go back and you're going to use that same one from the front, which is right here. I'm going to cut this out for me. There we go. Come on, there we go. I'm going to copy this to the other page so I can see it. Okay. All right, I need to use this and I need to fill out this chart. Do I have any that sum to 2? How many? 1. Okay, I have 1 out of how many? 36 that sum to 2. How many sum to 3? Everybody get that? This one and this one. 2 out of 36. Everybody know what you're doing? Can you fill in the sum probability distribution? How do we distribute the chances of getting those different sums? Fill your table in now. How many chances of getting a 4? 3. There's a pattern here. How many chances of getting a 5? It's like a diagonal pattern. Imagine that, yeah. So if I want to count 5, it's 1, 4, 2, 3, 3, 2, and what? 4, 1. 4 chances out of 36. How many chances of getting a sum of 6? 5. So we get 5, 1, 4, 2, these. So that would give me 5 chances out of 36. How about sum of 7? 6 possibilities, 6 times. How about 8? 5. 5 out of 36. Every time I get down to here. Sum of 9. 4 chances. Anybody want to predict what the next one's going to be without even looking? 3. And then it would be what? 2, and then it would be 1. Kind of interesting, isn't it? Can you answer those questions? What is the probability that the sum is 9 or greater? Now that's where those phrases that we looked at the front. 9 or greater. What do you think? 9 or greater. Would it be 10? So I would cut it off right here. The chances that it would be 9 is 4, but it said or greater. Well, 10 is greater, so that gives me an extra 3. Then I get an extra 2. Then I get an extra what? 1. So that would be a total of what? 10 chances out of 36 because it says 9 or greater. What's the probability the sum is 2 or 3? 2 or 3. What is it? You can talk. 3 out of 36, right? Probability I get a 2 is only one chance. But if I say or a 3, that's going to increase my chances. I'm going to have 2 more. That's 3 out of 36. What is the probability the sum is at least 3? Does at least mean it could be more than 3, or does at least mean it has to be less than 3? At least 3. Is that more or less? It's more. At least 3. Think about it like this. You know how sometimes you might go and you go to a yard sale or a bargain place, and you may say, well, let's see, I'm selling this bicycle. At least I'll take, mentally you're thinking, at least I'll take 20 bucks. If somebody comes up and says, that's a nice bike, I'll give you $30 for it. Would you turn it down? No, at least you'll take, but you'd like to have what? More. So it says at least 3. So what would it be? At least 3. I have 3 chances of at least 3. Is 4 at least 3? Yep. Is 5 at least 3? How many chances? There's 35 chances that I'm going to have at least a sum of 3. It means I only have one chance I can lose. So if I was rolling the dice, that would be great odds, wouldn't it? What is the probability the sum is greater than 3? Is that the same answer I just talked about? Greater than 3. Does it include 3? Greater than 3 would say, no, it can't be a 2, it can't be a 3, it has to be greater. If 3 is not greater than 3, so I can't use these first two. So now how many would I have? Take away the one chance and the other 2 chances. Now I have what? 33 chances out of 36. Am I making sense here? Is everybody kind of getting what we're doing? Okay. What sum occurs the most? 7. When you add all the probabilities, what do you get? You get 36 out of 36. What does 36 out of 36 the same as? 1. That means that basically you got 100% of it. So if you have all of the probabilities that are distributed across the table, you should get 100% or 36 out of 36, or it should equal 1. Everybody good with that one? Tonight you're going to be asked to do some things. All right, keep going. We already done that one. Okay, probability for the larger of the two. Probability for the larger of the two. We're going to do another probability distribution. I'm still going to write down my probability, but now I'm going to write it down comparing the two numbers and which one's larger of the two. Okay, so let's just take one. Take a look at your distribution table from the same thing. Now we're on the back, aren't we? But now it's still talking about that table from the front. That same table. Let me see. See if I can paste it in. What's the probability that 1 is the largest of the two numbers? There's only one time that 1 is the biggest number, right? Between 1 and 1, guess what's bigger? 1. That is only going to happen one time out of 36. Sum, it says which one's the larger, comparing the two numbers. What is the probability that between the two numbers, 2 is the largest? How many chances? If I compare 1 and 2, is 2 the larger one? Yes. 2 and 1, is 2 the largest? Yes. 2 and 2 is 2 the largest. So how many times? 3 out of 36. Everybody understand what we're doing? We're comparing the two numbers. And now, what's the next number? 1 could have been the largest. 2 could have been the largest. What's the next number? 3. How many times, if we compare numbers, is 3 the largest number? It's going to start getting bigger, isn't it? 3 and 1. 3 and 2. 2. Here's 3 and 4. Is 3 the largest, though? No. How many? Did I miss one? 3 and 1. Yeah, you're right. So how many is that? 5 out of 36. You finish it. 4. Huh? See if you can make sure you know how to do it. So if I do 4, circling when 4 is the greatest, it's kind of nice to have something there. Did you get 7 out of 36? Okay, what'd you get for 5? 9 out of 36? What about 6? 11 out of 36. So again, a pattern, right? Okay, now it says, when is this, so what is it? What is the probability that the larger of the two numbers is 3? Aren't you just is 3? Aren't you just pulling that straight out of the table? In that case, you just reach and grab it and say, okay, there was 5 chances out of, 36. I skipped one, didn't I? Yeah, no, we didn't. What's the probability that the larger number is 2 or 3? 2 or 3. 8 out of 36. What's the probability the number is at least 4? At least 4. Does that mean I want it bigger than 4 or less than 4? Bigger than 4. Can 4 be included? Yes. So I'm going to say this number plus this number plus this number is what? 27 out of 36. What is the sum of all the probabilities in the distribution? 36 out of 36 or 1? Okay, this time we're going to do the difference, and it's the absolute value of the difference. Does everybody know what I mean by absolute value? We're going to mentally subtract the 2, and then we're going to do the absolute value of the difference. So if I say 1 subtract 1, what is the difference? 0. Everybody got it? The difference is 0. How many times is that going to happen when I mentally subtract and get 0? It's going to happen here, 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 and here, right? 3 subtract 3, 4 subtract 4, 5 subtract 5. Now, it doesn't matter the order because it says absolute value of the difference. Did y'all catch that? So if I said right here, if I said 5 or 6 subtract 5, no, let's do 2 subtract 4. What's 2 subtract 4? Negative 2. But what's the absolute value of negative 2? 2. It's just 2 units difference. So the order really doesn't matter. Does everybody get what I'm saying? Okay, now complete the probability distribution. There may be a pattern. Difference is 1. I see a difference of here 1, difference of 1, difference of 1, difference of 1. Is that the only place? No. Difference of 1, difference of 1. Did y'all catch all those? Those all have a difference of what? 1 unit, and that's absolute value. So the order of the numbers is not so important. How many chances is that? 10 out of, right there's 16 of my 36. Okay. Difference of 2, difference of 3, difference of 4, difference of 5. So difference of 2 was 8 out of 36. I'm going to erase. How about a difference of 3? See, 1 and 4, 2 and 5. So we're seeing, y'all seeing the pattern, right? So how many? 6 out of? How about a difference of 4? 4 out of 36 and a difference of 5. 2 out of 36. So we did have a pattern, but it might not have been the pattern we first expected. Okay, can you answer these questions? Okay. What is the probability that the difference that should have said at least 3. That's what I meant to say, at least. Is at least 3. At least 3. Does that mean it can be 3 and more or 3 and less? 3 and more. So 3 and more. 6 plus 4 plus 2 makes 12 chances out of 36. What is the probability the difference is at most 2? Does that mean I want 2 and less or 2 more? 2 and less. Does it include 2? Yes. So I would include 2, which would means I'd include 8 plus 10 plus what? 6. At most 2. It means that's the most you have. Then you can have less, but you can have the most 2. So I'd be what? 24 out of 36. What's the sum of all the probabilities in the distribution table? We added 6 plus 10 plus 8 plus 6 plus 4 plus 2. We would get 36 out of 36, which is 1. Okay, does that complete most of our notes? Okay. Summary. This is really quick. A blank blank shows all the possible outcomes. Nope. The very first thing we did. Sample space. I think that was actually the very first sentence at the top, wasn't it? Did I put that at the very first somewhere? Is it on there somewhere? Okay. While a blank blank is a 2-column table showing numerical outcomes. You said it. You said it. It is a probability distribution. The key is we did a 2-column format, and we just organized our probabilities that way. The probabilities in the distribution should always sum to 1. Okay. At the bottom of the page, I think it's at the very bottom, I think there are 3 items. There are 3, yeah. If you flip a coin, heads or tails. Basically, that's your sample space, isn't it? If you flip a coin, did you know technically there's a third possibility? What's the third possibility if you flip a coin? It'd land on its side. However, the chances of that happening are so incredibly remote that most of the time we just say it's either what? Heads or tails. So, and we say that with equal probability. So you have 50% chance of heads, 50% chance of tails. So that's your sample space. It's already showing for you, and it's going to ask you, I think, to do a probability distribution. Don't skip number 3. It's going to ask you, I think, to think about tossing 3 coins. Draw your own sample space. If you need to go to another piece of paper, please do. I didn't want to use a lot of extra room and have to go to another sheet of paper, so there's not enough room for you to perhaps do everything. So if you need to go to a separate piece of paper, do that. Don't skip out on doing these first items. This can be a really easy unit, but probability can get tricky as we go for the next 3 days. So don't slide over any homework. Make sure you do it.